right, let me pass out your new packet for you. This is a notes and homework packet. This is just activity 17. Go ahead on the front, above where it says geometry, or the back of the colored sheet. I want you to draw an umbrella on the front or on the back of the colored sheet. Draw an umbrella. Do you guys remember drawing an umbrella before? Does anybody remember the title of the overarching topic that we're talking about, or did talk about? Start. Close. Close. Transformations. Yep. Transformation, which means to change. Like if you played with Transformers, they changed into a car or a person or whatever. Transform. How many ways can we transform? 4. We've studied 3. Today is the 4th. So let's review the 3 that we've already done. And we'll do our new one. Many of you have already said the other ones, which are, first of all, translation. Sounds similar. Translation. That means to do what? Slide. Yep. Slide. Left, right, up, down. What's another one? Ooh, that's today. Reflect. Which means to flip like a pancake. Another one that starts with R. Rotation. Which of course means to spin. We use patty paper a lot for these, especially rotations, because those were the hardest. We can pull out that patty paper if we review these, but today we're only focusing on the new one. And it's impossible to use patty paper for a dilation because dilation means it gets bigger or smaller. And I can't make your patty paper get bigger or smaller. So we won't be using it today. Let's write down the new one. Dilation. Raise your hand if you've ever gone to the eye doctor and had your eyes dilated. Not fun, right? Hate that. That's when your pupils get a lot bigger, and then over time they go back to their normal size. But dilation means the whole figure gets bigger or smaller proportionally. Kind of like if I have this photo. If I want to make that photo bigger, oops. If I want to make the photo bigger, here's how I do that. I take the corner and I drag the whole figure, both sides. I don't do this. Let's see if it'll do it. Never mind. I thought I could drag it one way or the other. Well, good. This does things the way it's supposed to. Notice this. Everything is getting bigger. The length is getting maybe twice or 3 times as big. The height 2 or 3 times as big. Proportionally, they're getting bigger by the same amount. It's not like people just get taller. That's what a dilation is. We have to make sure everything gets bigger or smaller by the same multiple. Okay, flip to today's notes then, 17.1. Here's our situation. I'll read it for you. Graphic artists create visual information for electronic and print media. They use graphic design software in their daily work. For example, a graphic artist can use computer software to design a brochure. That should say the text and art for the pages for the brochure can be moved around or scaled up and down before the actual brochure is printed. Kate is a graphic artist. She wants to create 2 different layouts of a brochure for her clients to review. The art for the layouts is shown below. I have layout A here, and I have layout B. Number 1, what are the coordinates of the vertices of the pre-image shown in layout A? Now that's kind of wordy. Let's break it down. What are the coordinates? 7, 2. That's what we're looking for. The coordinate of the vertices. The vertices are your 4 corners of the pre-image. This is our pre-image because nothing has been done to it. This is going to be our image. It's the after effect. So let's write the coordinates of the vertices of the pre-image. So here we go. A, B, C, and D. A, would we say 8, 0 or 0, 8? Correct. 0, 8 over 0, up 8. B, 6, 8. Fill in the rest. Number 2, what are the coordinates of the vertices of the images shown in layout B? Could you please change something on your notes for me? Please label these A prime, B prime, C prime, and D prime. And when you go about labeling the coordinates, make sure you label them prime. Go ahead. Zero 4, 3 4, 3 0 0 0. Number 3, what relationship do you notice between the coordinates for layout A and the coordinates for layout B? Whatever you say has to be true for every point, for every X and every Y. If you look here, 0 to 0, no change. 8 to 4, can I just say subtract 4 and everything subtracted 4? No. What happened that happened to every X and every Y? Yes, you can write that down. Dilate, or it got smaller by a half, right? Something like that for number 3. Dilated or got smaller by a half. That's true for every X, even 0. Half of 0 is still 0. Half, half, half. It worked every time. Number 4, express the transformation in item 3 as a function. When it asks for it as a function, it's looking for this. XY, arrow sign. All we have to do is write what we multiplied by. So if I multiplied by a half, I'm going to write half of all the X's and half of all the Y's. Okay, let me go back to this page for a second. Back when we wrote these, translations were sometimes written like this. Reflections might be written like this. Reflect over the line, X equals 2. Rotations might be written like this. Rotate over the point 3, -7, 90 degrees clockwise. Do you recognize this sort of information? Good. The way we write dilations is this. D for dilation. And then we're going to write either O for origin or 0, 0. You might see it both ways. O for origin, or 0, 0. And then you'll see the scale factor, which in the one we just did was a half. We will always dilate about the origin. In the honors geometry class, sometimes they take a couple topics here and there a little bit deeper. They don't do a whole lot of extra stuff, but this is one topic that they go a little bit farther. They dilate about any point on the grid. We will always dilate about the origin, so you will see always 0, 0 or O for origin. So that's what I'm going to write by this one that we just did. This was a dilation about the origin. That 1/2 is called our scale factor. We'll talk about that in a minute. Okay, let's flip the page. 5, 6, 7 you're going to do on your own. It's pretty much a repeat of what we've just done. I'll read it for you. Kate created a third layout for the clients to review. What are the coordinates of the vertices shown in layout C? Then what's the relationship? And then write it as a function. Go ahead. You're comparing layout A, the original, to layout C. Let's call it double prime. I'm going to go ahead and copy my originals also so that I can compare my originals to layout C on the same page. Did you notice a relationship? You have the function done. Okay. X, Y. And then I write, what am I doing to every X and Y to change it? It looks like every X is multiplied by 2. And every Y is multiplied by 2. It should always be the same number. Otherwise, it's not a dilation. It will always be the same number. And if it's not, it can still get bigger or smaller, but it's not called a dilation if we're not doing the same number for X and Y. We might see it written like this, but if it says as a function, it's referring to that. All right. You will see a box that says scale factor. I would like you to write this formula for scale factor in that box. They use K for the letter, just like slope, they use M. For scale factor, they use K. Here's the formula. P prime over P. Okay, now set your pencil down for a second. I'm going to copy that formula again so you can see kind of where it comes from. The scale factor is P prime over P. Watch what happens if I take one of the numbers from the prime points. Let's say 4. 4 over what it corresponds with, 8, is a half. 3 is from this prime figure. It goes with 6, and when I simplify that, I get a half. If we do this in the reverse order, we are not going to get the right answer. So anytime you're asked for scale factor, take either the x or the y from any prime point. Then divide it by its corresponding original point. Questions on that? We'll do that more in a different lesson. This is just sort of an introduction. All right. You can pick up your pencil. A dilation, which is one of the 4 main ways to transform, says a dilation is a transformation that changes the size of a figure, but not its shape by a scale factor k. It will change the size, but not the shape. It changes it by that scale factor k. Factor means multiple, so that's why we use the word factor. The scale factor determines whether the transformation is a reduction or enlargement. Number 8. What is the scale factor for the translation from A to B? I just had that up. The scale factor for the very first one was a half. Is layout B a reduction or an enlargement? What do you guys think? Yeah, reduction. It got smaller. Pretty quick questions. Same questions again. What's the scale factor for the transformation from layout A to C? That would be this one. From A to C, our scale factor, our multiple was 2. Is layout C a reduction or an enlargement? That was enlargement. Now 2 sort of conclusion questions. In general, for what values of scale factor k is the dilation going to be a reduction? And then the same type of question again. In general, for what values of scale factor k is the dilation an enlargement? Yeah.
Anything under 1
is going to be reduction?
Yeah.
Very good. Let's write that down. I'm actually going to have a lower bound at 0 just because we can't have negative. You will never have a negative scale factor. So yes, under 1 or from 0 to 1. So Colton, what does that mean? Your scale factor is going to be if it's an enlargement.
Anything above 1.
Yes, k is greater than 1. What happens if the scale factor is 1? It's the original. If I multiply anything by 1, it's the same. It wouldn't get bigger or smaller. I would say that's not really a dilation. Here's what a lot of students tell me. See if you can find the flaw in this statement. They tell me for it to be a reduction, it has to be a fraction. They say a fraction will result in a reduction.
5/4.
There you go. Yeah. The fraction 5/4, isn't that bigger than 1? That's going to be an enlargement. So I know what you mean, and many fractions are reductions, but that's not always true. So try not to say a fraction. Try to say less than 1. Okay. The last page. Given points A, B, and C, perform the following. I don't want you to do any of that yet. I just want you to plot and label these 3 points. You can go ahead and count by 1. Make sure you've labeled your points. A, B, C. All right, I wrote this bigger so that we can discuss this. Maybe make a note. I know you know it today, but will you remember it in a few days? Let's see. This stands for what? Origin. You do nothing with that. That's just information. That means origin. That means where we're dilating from. The half is K, which we call the scale factor. What do we do with that? We multiply every X and Y by that. Every X and every Y is going to get multiplied by a half. So let's go ahead and do that. Let's find our new points by multiplying every X and Y by our scale factor. I'm starting with A. A is 2, 20. So let's multiply 2 by a half. 1. 10 times a half. Sorry, 20 times a half is 10. Go ahead, you don't need a calculator. Take half of every X and Y. Plot and label these new points, and then you're done with this question. What do we say? This is pretty easy. Awesome. I'm going to have you guys do number 12 on your own. It's a repeat of what we just did. I gave you 3 new points. I told you the scale factor. Please plot the original ABC and then plot your new points. Try not to look up as I'm doing mine. Questions on number 12. Check your paper, make sure you have A prime, B prime, C prime. Those are easy points you don't want to miss on a quiz just because you forgot to label. All right, lastly, we have some sets of triangles here. This first set are exactly the same. What do we call that when they're exactly the same? Equal or, starts with a C. Congruent. Write down congruent. With a little symbol. That's what we have on those posters over there. Several sets of triangles that are congruent by side, 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 side against side, HL, etc. I can get a congruent figure when I translate it, rotate, or reflect it. The figure will still be congruent. Let's take a look at what happens with the sides and angles. Please look at the board. You don't need to write anything right now. Here's my 3 sides. I think we already know this, but they are exactly the same. Every side matches with every side. Every angle is the same size. So write down the sides are always congruent. The angles are also always congruent. These figures over here are not congruent. These two are what we call similar. Means a dilation has taken place. It's the same shape, different size. They are not congruent. They're what we call similar. That symbol is just the squiggly line. Let's compare the sides and the angles. Obviously, the sides are different. They're not all the same anymore. These 3 don't match. They are what we call proportional. So the bottom side might be 2/3 of what it used to be. This side's 2/3 of what it used to be. Maybe that side's 2/3 of what it used to be. We call that proportional. Proportional. P-R-O, portion, P-O-R-T-I-O-N-A-L, proportional. Let's look at the angles, though. This bottom angle matches. This angle is the same size, and this angle remains the same size. So your angles remain congruent.